Okay, so yesterday we started talking about comparing fractions. We're going to keep going with that today, and we're going to continue working with comparing fractions. So right now I want you to open your math journal to the notes page that we started on yesterday. I believe it was page 22. We did not officially take our notes in there yesterday, but go ahead and get it out because we will be taking those today. Okay, I apologize, it was page 23. All right, we're going to watch our video one more time on comparing fractions. So I want everyone's attention up front. Please put your pencil down. I know one pencil's in your hand, so know that you're paying attention. Okay, give your attention up to the front.
Fractions can be tricky when they have unlike denominators. How can you compare fractions? Think about this question during the lesson. Isabella's father is building a model dinosaur with small pieces of wood. The pieces of wood measure 4/10 of an inch, 1/4 of an inch, 5/8 of an inch, and 4/5 of an inch. What fractions are you given in this situation? The fractions are 4/10, 1/4, 5/8, and 4/5. How do the pieces compare? Let's find out. Compare 1/4 and 5/8. Then compare 4/5 and 4/10. There is more than one way to compare fractions. The fraction 1/2 can be used to compare some fractions. Use 1/2 to compare 1/4 and 5/8. Use fraction strips. Compare 1/4 to 1/2. Use one 1/4 strip to show 1/4. Is 1/4 greater or less than 1/2?
Okay, is 1/4 greater than 1/2 or is it less than 1/2? By looking at the fraction strips on the video, is it greater than 1/2 or less than 1/2? Kobe?
Less.
1/4 is less than 1/2. What if we didn't have the fraction strips here to show us visually? How would you know that one would be less, Jaden?
Because you could like if you could
You want some help? Cherish, help him out.
the one with the smaller
Okay, remember, if we're sharing, for instance, a pizza or a piece of candy, okay, if we have one whole pizza and it's cut into half, our denominator is 2, right? So we're going to have a pretty large slice of pizza. If we're sharing a pizza with 4 people and we're cutting it into 4 slices and we only get one piece of those, the pieces are going to be a lot smaller. Okay, so when you have the same numerator, remember the fraction that has the largest denominator is going to be the smaller piece. Okay, because you have to share with more people. Okay, so our original fractions that we were comparing here was 1/4 and was it 5/8?
Yeah.
5/8. So did we say 1/4 is less than or greater than 1/2?
Less.
Okay, so we know 1/4 is less than 1/2. What about 5/8? Is 5/8 less than 1/2 or is it greater than 1/2?
Greater.
I hear some less and some greater. Who thinks it's greater? Raise your hand. Hands down. Who thinks it's less than? Raise your hand. So you're saying 5/8 is less than 1/2?
Yes.
Okay. Hands down.
No.
I want you to explain that to me. Who thinks 5/8 is less than 1/2? Who thinks 5/8 is less than 1/2? Okay, Jocelyn, can you explain to me why that is?
Because 5/8 is less than 1/2 because 1/2 has a bigger piece and 5/8 has 8.
Okay. So let's say we have our pizzas again. Let's say, for instance, we have 2 pizzas. This pizza is cut into slices in 1/2. 1/2, another half, right? This one's cut into 8 slices, so 8. Okay? Let's color in 1/2 for the pizza that's cut into 2. And let's color in 5/8 for the one that's cut into 8s. 1, 2, 3, 4, 5. What do you notice about the picture models? What do you notice, Malachi?
That one have only has one shaded in, and 5/8 only have 5 shaded in.
That's true. That's true. There should be something else up here that you can see. What other observation do you have, Daniel?
That 1/2 only has 1 and 5/8 only has 3. That there's
Okay, so you're saying there's 1 left and there's 3 pieces left? Yeah, but are the sizes of the pieces the same?
Yes.
So this piece is the same size as this piece?
No.
Are the size of the pieces the same?
Yes.
Yes?
No.
So if you get 1 piece of this one, Brooklyn, if you get 1 piece of this one, look how much pizza you get.
I know you said pieces, not pizza. I thought you said pizza.
Yeah, are the size of, okay, you saw it said pizzas? Okay. Are the size of a piece is the same?
pizza.
Is this one slice the same as size as this one slice?
No.
No. Okay, can you tell by the picture models which one is more? Which one has more shaded in?
5/8.
5/8 has more shaded in, doesn't it? So 5/8 is actually greater than 1/2. So we can look at this and we say, well, I know 1/4 is less than 1/2, and 5/8 is greater than 1/2. So that means 5/8 has to be greater than 1/4. Does everybody understand? Does that make sense?
Yes.
Okay. I'm going to continue with the video, then I'm going to erase this in case we need this area for the video. I'm going to go ahead and continue with the video. Keep on paying attention. Y'all are doing a great job.
The fraction strips show that 1/4 is less than 1/2. Now compare 5/8 to 1/2.
And that's what we just
Use
did.
5 1/8 strips to show 5/8. Is 5/8 greater or less than 1/2?
What did we say?
Greater.
And remember yesterday we used our fraction strips to place our fingers on the 1/2 and place your finger on the 5/8?
Yes.
Okay, so you've got your fraction strips in your journal to help you if you need them.
The fraction strips show that 5/8 is greater than 1/2. So 1/4 is less than 5/8. The 5/8 inch piece of wood is longer than the 1/4 inch piece of wood. Why is 1/8 less than 1/2, though 8 is greater than 2?
Why is that? We talked about that a little bit a few minutes ago, but why is that, Brooklyn?
Because the bigger the denominator, the smaller the pieces.
Exactly. The bigger the denominator, the smaller the pieces that are being cut up or divided up.
Unlike whole numbers, when the denominator of a fraction with the same numerator increases, the fraction gets smaller. Why is using fraction strips one of the most reliable methods of comparing fractions?
And why did we say it's a good idea to use fraction strips, Daniel?
Because a lot of people have a problem with fractions when you don't have a fraction strip.
Okay. What happens if you don't have a fraction strip? That's a good question.
If you don't have a fraction strip, you can get a question wrong.
Possibly, but why is it easier to use fraction strips, Jaden?
Because you could just take your finger and go down and then slide.
So you can visually, it's like a visual representation that you can see with your eyes and use your fingers to follow along and really tell, can't you? So it's simpler to be able to understand it because you can see it visually.
Using fraction strips is one of the most reliable methods of comparing fractions because you can visually see the difference in lengths between the fraction strips. Another way to compare is to use equivalent fractions. Use equivalent fractions to compare 4/5 and 4/10. Use a number line. The tenths are shown below the number line. The fifths are shown above the number line. You can see that 4/5 is equivalent to 8/10 on the number line. Since 4/5 is equivalent to 8/10, you know that 4/5 is greater than 4/10.
And we talked about the number line somewhat yesterday
Now
as
you
well.
know how to compare fractions by comparing with fraction strips and by using equivalent fractions.
Alright, I want you to make sure you're opened up to page 23 in your journal. We're going to finish taking our notes for fractions. I want you to have all of these notes in your journal so that you can always go back to them anytime that you're struggling on your work. Zoom out. Okay. Alright, so we're going to look at the different ways that we're going to use the different strategies to compare fractions. Daniel, do you have a question? Okay, will you come back here and get one, please? Okay. Okay, so we're going to look at comparing fractions. Okay, how can we compare fractions?
Do you write this down?
Yes, ma'am. If I'm writing it in my journal, you are writing it in yours as well. How can we compare fractions? Okay, I'm going to write number 1. There's going to be 4 different ways that we're going to look at today for comparing fractions. Okay? The first way, if the numerator is the same, the smaller denominator is the larger fraction. Okay, so if the numerator, who can tell me which number is the numerator?
The top. The one on the top.
The number on top, good. If the numerator is the same, so if the top number is the same, the smaller denominator is the larger fraction. Say it one more time. If the numerator is the same, and you guys told me that's the top number, right?
Yes.
So that top number is the same. Then the smaller denominator, which number is the denominator?
The bottom.
The bottom number. The smaller denominator is going to mean that's the larger fraction. And I'm going to give you an example. I'm going to draw a model at the bottom of this. Let me give you an example of that. Yes, you may. Actually, I would highly encourage you to do it. Remember, I'm not doing this for my benefit. This is all to help you. All right, this first model, what fraction represents the model that we have right here, Malachi?
2/4.
2/4, good job. What fraction represents the model that we have right here? Haley? Go ahead, I'll wait. Okay, 2/8, very good. So you notice they have the same numerator, don't they? The only difference is the denominator. So the 1 again with the smaller denominator means it's a larger fraction. So 2/4 is greater than 2/8. Any questions on that method?
No.
Okay, our second one. I need you to wake up. We're not sleeping. Come on. Up. Head up. Our second method is if the denominators are the same. That means if your bottom number is the same, then the larger numerator is the larger fraction. Okay, so if the denominator is the same, the larger numerator is the larger fraction. And again, I'm going to draw a picture model to help you with that.
Do we have to draw circles?
Yeah. Or you can draw circles or you can draw bars.
Rectangles.
That's just the title. How can we compare fractions? All right, look at the first model I have. What fraction represents this first model right here? Malachi?
5/6.
Good job. What fraction represents the second model right here? Desiree? Right here.
6.
How many total pieces are there in this whole? 6, so that's my denominator. How many there are in the whole? How many are shaded in? 3 is your numerator. Okay, so 3/6. Okay, remember if our denominator is the same, let's think about if we decompose these into unit fractions. If we decompose 5/6 into unit fractions, what would we have? Who can help me out on that? If we decompose 5/6 into unit fractions, what would that be? 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. So we'd have 1/6 5 times, wouldn't we? What if we decompose 3/6 into unit fractions? How many times would we have 1/6? 3 times. Okay, so that means our 5/6 is larger than 3/6, and you can tell by your pictorial models here. Okay, so one more time, if your denominators are the same, your bottom numbers are the same, the fraction that has the larger numerator is going to be the larger fraction. Does that make sense? Anybody have any questions on that one?
Can you slow down some?
Who is not ready to move on? Okay, that's fine. All right, I'm going to go ahead and go down to our third way. So I'm going to move my notes up. Everybody should by now have the first one completely finished. Okay. All right, the third way is we're going to compare the fraction to a friendly fraction. And our friendly fraction is 1/2. Okay, just like we saw in the video. We're going to compare the fraction to and I'm going to say friendly fraction which is 1/2. Okay, for instance, if we had the fraction of 4/8 and the fraction of 8/12, and we're comparing these two fractions, let's first look at 4/8. Is 4/8 less than 1/2? Is 4/8 equal to 1/2? Is 4/8 greater than 1/2? Remember, don't blurt the answer out. If you haven't, just raise your hand. How does 4/8 compare to 1/2? Leoncio? How do you know 4/8 is equal to 1/2? Without drawing a picture. How do you know that?
Because, like, if you do multiplication by 4, you'll get it so
Okay. So 8 is basically 4 doubled. Okay, what do you say, Cherish?
Well, I think it's equal to because 4 is half.
Because 4 is half of 8. Very good. You're both correct. Okay. So we know that 4/8. Okay, we know that right there is 1/2. That is 1/2. Right? 1/2 is an equivalent fraction to 4/8 is equal. What about 8/12? Is it less than 1/2? Is it equal to 1/2? Or is it greater than 1/2? What do you think? What do you think, Malachi?
It's greater.
Why do you think it's greater? Why do you think 8/12 is greater than 1/2? You just guess? You don't have an explanation? Okay. Is there anybody else that thinks it's greater? I'm going to tell you something. You are correct, Malachi. 8/12 is greater than 1/2, but how do we know that? How do we know? Kiantre?
Because 8, the 12,
Tell her it's open.
bigger than 8, and so
We took it to the office already. Yeah, you're welcome.
we got more, time. And 12, 8, 12, and 4, 8.
Okay, think of it this way. What is half of 12?
6.
6 is half of 12, right?
Yeah.
Well, we have 8 12, so 6 twelfths would be 1/2, because 6 is half of 12. We have more than 6 twelfths, we have 8 twelfths.
That's
So we know because of that, that this is more than 1/2. Okay, this fraction is more than 1/2. So we have one that we know is equal to 1/2. Okay, 4/8 is equal to 1/2. And we have 8 twelfths that we know is more than 1/2. So which is greater, 4/8 or 8 twelfths?
8, 12.
Say it again, Kendra. 8 twelfths, because we know it's greater than 1/2. 8 twelfths is greater than 4/8. So we would say 4/8 is less than 8 twelfths. Any questions on that one? That's the one that we did in the video. Any questions? No? Okay, we've got one more way. Okay? If you try looking at the numerators and they're not the same, so then you look at the denominators and they're not the same, that means you can't use the first two methods to help you determine greater than, less than, or equal to on fractions. If you compare your fractions to 1/2, and for instance, both of your fractions you're comparing are greater than 1/2, it's hard to tell which of those is greater, isn't it? If both of the fractions you're comparing are less than 1/2, then it's almost hard for you as well to determine which of those is a greater fraction. So if you can't do either of these three methods that we already talked about, there's one more thing to do. Okay, and I'm going to turn, who's not ready to move on? Okay, quickly, because I need to turn my page over. I'm out of room. Okay, so I'm going to turn over to our last method, our last way to compare fractions. This is our fourth way, and this is the method you would use last if none of the other three would work. Get it off, please. Okay? Okay, for this last method, we have to create an equivalent fraction. And to do that, we have to find a common denominator, okay? And I'm going to show you how to do that today. This is one thing that we did not talk about yesterday, so this is new to you. Find a common denominator. So I'm going to compare the fractions 3/5 and 4/8. Let's compare these two fractions today. Malachi? Oh, I thought you had your hand up. I need you to sit on your pockets, please.
I do have my hand up, but I was just saying, can I do that one?
Oh, well, I haven't showed you how to do it quite yet. Okay? All right, now when we're finding a common denominator, we have to list the multiples for our denominators. Okay? We have to list the multiples for our denominators. And I know you can do this. Do you know how I know you can do this? Because remember when we did division and we made our list of egos? That's basically the same thing you're doing. You're making a list of those multiples. So for 5, you're listing 5, 10, 15, 20, 25, 30, 35, 40, 45, and I'm going to stop there. So these are all of my multiples of 5. So now I need to go over here for my other denominator of 8, and I need to list all of my multiples of 8, just like we did if we ever did ego 8, just like we did for that. Oops. So you start with 8. What comes after 8?
16.
Good. Who would read me this? Who can read me the multiples for 8? Who wants to read me? We haven't called on Kobe.
8, 16, 24, 32, 36, 40, 48.
Okay, I'm going to stop you right there because I already see something in common. Okay? I'm looking for the least common, okay? Not factor. These aren't factors. Least common multiple. Okay, and you're going to hear me refer to that as LCM, least common multiple. We haven't done that yet. No, this is new to us. Okay, so we look at, remember when we found greatest common factor, we looked at what the largest number they had in common is? Well, for least common multiple, we're looking for the smallest number that they have in common. So look here. Look at our multiples that we listed for the denominators. What is the smallest number that they have in common? Smallest number they have in common. Jorge, what do you notice? Smallest number that they share, that they both have. So let's start. Do they both have a 5?
No.
10?
Nope.
15?
No.
20?
No.
25?
No.
30?
No.
35?
No.
40?
Yes.
Ah, so I'm going to circle that 40. That means our LCM. What does LCM stand for?
Least common multiple.
Okay, one more time. Tell me what LCM stands for.
Least common multiple.
Okay, and what is the least common multiple? Raise your hand to answer, please. What is the least common multiple, Jorge? 40. But the least common multiple means the smallest number that they have in common. So our LCM is 40.
So it should be least number multiple.
Least common. Common means they have it in common. They both have it. They share it. Can y'all get y'all's feet off of each other, please? Cantree. Okay, so if our least common multiple is 40, watch what we do next. We have to create equivalent fractions for both of our original fractions. And because 40 is a multiple for both of them, we're going to create an equivalent fraction with a denominator of 40. Okay, so remember when we found equivalent fractions and they gave us either our numerator or our denominator for us? We have to look and see, okay, well, what do you multiply times 8 to get 40?
5.
We multiplied 5. 8 times 5 gave us 40, right? So that means we have to multiply our numerator by 5.
Okay.
And we have to multiply 4 times 5. What is 4 times 5?
20.
20. So 20/40ths is an equivalent fraction to 4/8.
Because it's half.
Now let's go over here. What did we multiply times 5 to get 40?
8. Be quiet. Stop yelling out.
Please remember, we're not blurting out or raising our hand. I'd love for you to answer, Jaden, but just raise your hand, okay? Jaden, what do we multiply times 5 to get 8?
8.
I said it wrong. What do we multiply times 5 to get 40? Times 8. So multiplying 5 times 8, which means we also have to multiply our numerator times that same number. So we have to multiply 3 times 8. What is 3 times 8? Natalie, 3 times 8. And if you forget, go back over here. Look at your multiples. 8, okay, 24. So 24/40ths is equivalent to 3/5.
I didn't say anything.
Oh, I thought I heard you.
No,
I apologize.
no, this is Grace.
Please don't blurt out. Okay, I called on Natalie. I should only hear Natalie's voice then. All right. So I now have two fractions that have the same what?
Denominator.
They have the same denominators. And remember, if they have the same denominators, we can tell which of those is greater because the one with the greater numerator is going to be the greater fraction. So what is greater, 24/40ths or 20/40ths?
24/40.
What's greater, 24/40ths or 20/40ths?
20/40.
Oh.
What is greater? Tell me, Regimen, is it 24/40ths or is it 20/40ths? Say it again. With confidence. 24/40ths is greater. That means that 3/5 is greater than 4/8. Because these right here where my fingers are equivalent fractions to these right here. Does that make sense?
Yeah.
Everybody understand?
Yeah.
Good. Any questions?
Nope.
Okay, this is probably our hardest method, but I think you can do it, especially if you use your journal, follow through step by step the way we showed you, and then you're all going to be great and successful. Okay, once you get this down in your journal, I want you to get out your math book, please. Get out your math book. Not your journal, your book. Follow directions. Following directions. Alright, I want you to open to page 537. 537, yes ma'am. Can you do what? Wait, will you open it? 537. And I want you to carefully, Jorge, tear out page 537. Please don't rip it. I don't have any extra pages. Once you tear it out, put your math book back in your desk. Put your book back in your desk. Page 537. I hear a lot of conversations. I'm going to go ahead and start my recess lift. If you're talking, you're going to give me some time there. Before we begin, please put your name on your paper. I had 4 papers I was grading yesterday that had no name on them, and I had no idea who they belonged to. Put your name on your paper now before we start. Alright, and we're going to look at the guided practice section and do guided practice together. Before we begin, I would like materials managers. Please get up, get a piece of notebook paper for each person in your group.
He ain't materials manager.
Brooklyn, I need you to stop blurting out and start raising your hand. Malachi, have a seat.
I'm bigger than you.
Okay, Brooklyn and Malachi, y'all are going to give me recess time.
Thank you. 9.
You're welcome.
morning, materials managers.
Oh, yeah, that's the material manager. You stay with green.
Kobe, who's your materials manager for your group?
Lucio.
Okay, it's not you? Then why are you up? I'm going to go ahead and put your name down also for not following directions. Leoncio, have you gotten paper for your group members?
No,
Why is Kentry doing it? Kentry, are you materials manager? Who is?
Hey.
Green table, who is y'all's materials manager?
Lucio.
Okay, Kentry, your name's going down too. Leoncio, I need you to get up and do your job. Daniel, will you turn the light on, please? Okay, we're not making a good decision right now. We need paper because there's not enough room on some of these problems to solve it, so you need to have paper to work it out. All right, we're going to look at guided practice sections together. It says in numbers 1 through 4, write greater than, less than, or equal to. Use fraction strips or drawings to help. Make sure you keep your math journal out. You have fraction strips in your journal, and we have notes in our journal to walk us through 4 different ways to compare fractions. Okay? So number 1 on guided practice, we're comparing 3/4 to 6/8. Okay? We have 3/4 and we have 6/8. So let's first think, do we have the same numerator?
No.
Do we have the same denominator?
No.
So we can't use either of those. Okay, let's see if we can compare them to 1/2. 3/4, greater than, less than, or equal to 1/2.
Greater.
Good, Ariane. No, you're right, it's greater than. What's half of 4?
4. I mean 2.
2, so 2/4 would be a half, so this is greater than that. So this is greater than 1/2. Let's look at 6/8. What's half of 8?
Half of 8 is 4.
4, so 4/8 would be a half. Is this greater than or less than?
Less.
Greater.
If 4/8 is 1/2, is this greater than 1/2 or less than 1/2?
Less.
Kobe? Okay, stop. I'm going to stop you right now. Do not blurt out because everyone's blurting out. Most of you are blurting out the wrong answer. You're not even looking and you're not even listening and trying to understand. You're just shouting whatever you want to shout out. We said 4 was half of 8. Yes?
Oh.
So 4/8 is 1/2. We have 6/8 here. Is that greater than 1/2 or less than 1/2?
Less than 1.
What did I say about blurting out? No, I didn't. That was a long time ago. 4/8 is 1/2. Do you really think it's good to argue? 4/8 is 1/2 because 4 is half of 8. Does everyone understand why 4/8 is 1/2?
Yeah.
We have 6/8. Is 6/8 greater than 4/8 or is it less than 4/8?
Less than 4.
6/8 is less than 4/8?
No.
Y'all are really scaring me. Cherish? Greater than. 6/8 is greater than 1/2. So if we have 3/4 is greater than 1/2, 6/8 is also greater than 1/2, we can't use that method to determine which of these is greater than, less than, or equal. So we need to find an equivalent fraction by finding a common denominator. Okay, so everyone, I want you to write this on your notebook paper. Get out your notebook paper. We're going to find a common denominator for our 4 and for our 8. So we have to write down our multiples. Okay, someone read me your multiples of 4. Read me your multiples of 4, Jocelyn. Multiples of 4.
4, 8, 12, 16.
Okay, I'm going to stop you there. 4, 8, 12, 16. Read me your multiples for 8, Arion.
8, 16.
Stop there. Only reason I'm stopping there is I already see something that they share. We don't need to keep going if we already see something they share. Remember, we're looking for the LCM. Tell me what LCM stands for, everyone. Okay, one more time, everyone.
Least common multiple.
Okay, but we're looking for the least common multiple. What's the smallest number that they share, Anastasia? The smallest number they have in common. 8? Anastasia says 8. Does everybody agree with her?
Yes.
I agree as well. 8 is the LCM, which means we have to find an equivalent fraction for each of these with a denominator of 8. Okay, so let's go to this one. If I'm making an equivalent fraction with a denominator of 8, what did we multiply to get 8? 4 times what?
8, 2.
4 times what equals 8, Jaden? Times 2. So that means we have to multiply our numerator times 2. What is 3 times 2?
6.
6. Look over here. 6 8. So we already have a denominator of 8, don't we?
Yeah.
So we don't have to find an equivalent fraction because that denominator is already 8. So now I can look at 6 8 and I can compare it with 6 8. What do you notice? Greater than, less than, or equal to? Very good. 3/4 is equal to 6 8. How do we feel? Good? Okay, I'm going to give you about 5 minutes. I want you to work on number 2. Work on number 2 with a partner. Nope, Cherish Daniel together. I'm going to let the 3 of you together, unless I bring somebody over in a second. I want the 2 of you together, the 2 of you together, the 2 of you together, 2 of you, 2 of you. Jaden, come over here and work with Brooklyn. Brooklyn, you're working with Jaden. Okay. Give you about 5 or 6 minutes. I want y'all to work on number 2 together. Go ahead and go. Why are you not doing this? We're not doing this. Huh? Yeah, we're still doing guided practice. Work with your partner. Not right now. Why did you get that? How did you know that so quickly? How did you know so quickly? Ah, very good, very good. Huh? Yes, good job. So what if you did not have that? Did you still do it? What are we doing over here? They do, so what do you need to do? What do you need to do? They have the same numerator. What happens? Okay, so which way does it go? Yes, way to go. Good job, good job.